So welcome to all of you for the webinar. This webinar is a part of the ongoing webinar series of CloudSiksha. The CloudSiksha Academy plans to have webinars at regular intervals. We will have webinars on various topics, a bit technical, sometimes a bit non-technical, mostly on clouds, DevOps, storage, multiple subjects we would be having the webinars. And it will happen on the weekends, and we will be recording these webinars, which you can again later watch. The way I will be going about is first, I will give you the idea about NoSQL and about the DynamoDB. And once I finish that, you can ask questions. Of course, we'll be having only an overview of the subject because we won't have time enough to go deeper into it. But of course, if you are interested, you can always enroll in the CloudSiksha Academy, where I have given much more detail about DynamoDB and other things in the courses there. Yeah, Prashant has joined, so let me just say hi to him before I start. So what I'm going to do now is I will go ahead and share my screen and the slides. And that point in time, of course, you won't see me, and I'll get the slides going. And as I said, towards the end, after I finish, because when I get the slides, I may not be able to see your comments on the chat. So the last 10-15 minutes we will devote to question and answers. At that time, you can put up your questions. If you're putting up your questions before, it's fine. I'll see them and answer you once I finish this. So let me start by sharing my screen, and we'll get into the presentation mode. So I want to get this into the presentation mode, and let me start from the beginning. Here is your presentation on NoSQL and DynamoDB. So let's first find out what is NoSQL. Now, NoSQL has different meanings. Sometimes people say there is no SQL there, in the sense that there is no query and other things happening. And other cases, they say this is not only SQL. Now, NoSQL has multiple data models, basically something like key values, documents, graphs, etc. The basic thing about this is that you will not need a predefined schema in order to work with this. That is, in a normal database, that is in your RDBMS kind of database, you will need to first define a schema. That is, you first have to take a table and say how many columns it has and so on. But in NoSQL case, it is not necessary. The reason why NoSQL is used in most places is because of its scalability and performance. They take precedence over reliability whenever there is such a need. The normal RDBMS databases are difficult to scale, whereas NoSQL databases are so structured that they can scale well. The NoSQL, of course, has certain limitation, that it doesn't provide the standard asset guarantees that a database would provide, like atomicity, consistency, isolation, and durability. That is provided by normal RDBMS, whereas in NoSQL you won't get that guarantee. Similarly, you don't need to perform joins and so on. So what does this mean about not having a schema? What does it mean that you don't need it? I will tell you when I speak about DynamoDB, and if possible, I will give you a demo of DynamoDB where you will understand what a non-schema oriented NoSQL is all about. Now, let us look at some of the non-SQL databases. It's wrongly mentioned as SQL databases here. It's actually NoSQL databases. This NoSQL databases are of different kinds. One is called as a key value. So you don't store data in rows and columns. Rather, you input a key and you input a value for that key. That examples of this are DynamoDB and Redis. There are many more, but these are just a couple of them. DynamoDB can be seen as both a key value database as well as a document database. So what is a document database? Document is key and document. So you have a key, and then on the other side you have a document. You don't have a value, but rather the value is a document. I will show you in the next slide how it works. What is that? Then you have columnar databases. These databases store the columns as units. Redshift is an example. In future, we will be doing a webinar on Redshift. There I will discuss the columnar database and how it is structured in detail. For time being, just let it be known that columnar database works very well when you have to read and do some data analysis. Then there is the graph database. Here, values are linked to each other as a graph, so that it is easy to do certain search. For example, you are related, A is related to B, B is related to C. How far is C from A? Type of a relationships. Those relationships can be handled by this graph database. So these are the popular NoSQL databases. Once again, sorry for the title here. It is a NoSQL databases, not SQL databases. Now, here is a simple example. I'm giving this because there's something which we would use in DynamoDB. For example, you have a key value. Key value is, I would say the key is company. The value could be CloudSiksha. Now, here in a document database, the key could be something like details, right? And the document could be this JSON document that I've shown here. You have a JSON document that is seen here. This JSON document becomes the value. The key could be company details, and this document becomes the value. So this is the difference between key value and a document database. In a key value, there's only one value associated with a key, whereas in a document database, you have a key and the value is a document. The document is generally a JSON document or an XML document. One of them can be done here. So what happens as far as NoSQL databases, as I said, are concerned, is that they are not based on rigid schemas. They are flexible. So what is this flexibility? How is it done? I will take DynamoDB as an example and give you an idea of what it means not to have a schema. Let's go to DynamoDB. Now, in DynamoDB is a NoSQL database. It's what is called as a distributed database. What does it mean, a distributed database? It means that the database is not stored in one single disk. Rather, what Amazon does in case of DynamoDB is that it uses a lot of SSD storage to give you a very fast and very seamless scalability. So there are a lot of SSDs on which you store your data, and the data is distributed across these by means of what is called as a partitions. I will explain to you what is partitions in the coming slide. But the data is partitioned and stored across a huge number of SSDs, so that when you want to retrieve, you can retrieve much faster than what you would do if you stored everything in one single disk. The disk could be a RAID 10 type of disk. Still, it wouldn't scale to what sort of scaling that DynamoDB offers. So DynamoDB's distributed database offers you excellent scaling and excellent performance. Okay, so you basically create tables. Now remember this, here a table just means it is a container to hold your data. It does not mean row and column. They use the same terminology here as a table, but table here is just like, if you are familiar with S3, it's like, you can think of it like a bucket. So you just have a particular table as a storage unit, not as row and column. You don't define anything at all. And in that, you start putting your data in form of items. I'll come to that there. And you can also scale up the table's throughput capacity without any downtime. That is, you can tell that I need much faster read-write performance, or sometimes you can scale down the requirement. Now, why would you want to do that? That is because the more faster you want your read-writes to happen, the more costlier it is. So that's the reason why you may want to scale up and scale down your capacity. Let's look at the core components of DynamoDB. And I will also explain once again how the non-schema type of model works here. Now, before I go here, let me try defining a need for storing certain data. Let me take a case of, let's say you are having a stationery shop, let me say, or you are having a bookshop which also sells the stationery. Now what happens here is that you have to store data related to the books. Now book has certain attributes. So the book has attributes like, what's the title of the book, who is the author of the book, who is the publisher of the book, what is the price of the book, whether it is hardbound or paperback, and so on. And sometimes people may say, hey, the new book comes, I may have to get more attributes here and all that. That is one part. Let's say in the shop, you also have pens that you want to sell. So in the pens case, the attributes are going to be different. Like you may have the color of the pen, the material of the pen, the brand of the pen, whether it's a fountain pen or whether it's a ballpoint pen, and so on and so on. So again, in that, you may want to have the option of adding more attributes as it goes on, like this. So what may happen is that you may design your database with different tables. So one table for book, one table for pen, and one table for diaries, one table for markers, and so on. Now, when you want, somebody comes to your shop and asks you, like, I need to buy a present for someone, and I need something which costs me $10 or $20 or something like that, then you need to do some complex computation across tables. Maybe you're doing some joins and all that, and then get the value out. Now, in a NoSQL type of a thing, you don't need to worry. What happens in DynamoDB, I take this as an example, is that DynamoDB lets you store items. And these items don't need to be related to each other at all. What happens? The first item could be a book, and book has its own attributes. Those attributes we see here is the attributes of that item. So the book has its own attribute. You store a book. The next one you get, you go ahead and store another item with attributes which are the attributes of a pen. So what are the attributes? Attributes are the actual key value pairs. So your attribute for an item, the first item you store could be a book. The book could have attributes like title, name of the author, price of the book, ISBN number, and so on. The other item can have a totally different set of attributes like color of the pen, material, type of pen, brand of pen, etc., etc. So in the same table, you can keep on putting in items. Each item could be having different attributes. So if you want to go fetch an item from this table, then for that you require something called as a primary key. The only thing in DynamoDB which every item must have is a primary key. That is mandatory. You must have a primary key for each item. And you can also have secondary index. I will talk about secondary index and DynamoDB streams later. Let's first go to check about tables, items, and attributes. Right? Table is a collection of items. So first you define a table, but table here is not, as I said, a row column type of thing. It is a collection of items. And very important thing you have to remember about DynamoDB is very similar to S3 in terms of storage, in the sense that there is no limit to what you can store, how much you can store. That is, you keep on adding items, you will keep on getting space. In the sense, unlike an RDS instance which you take in Amazon, where you have to define or where you have to first provision the storage. It could be 6 terabytes or it could be 16 terabytes or whatever, but you have to right in the beginning tell what is it that you want. Whereas in the case of DynamoDB, you don't need to tell anything. In DynamoDB, automatically, as soon as you keep on adding items, more and more space will be given for you. Right? That's what happens. So what is an item? Each table will contain multiple items, right? And there are going to be at least one attribute which will make it uniquely identifiable. You can think of them like a row in RDBMS, but it's not exactly like that. Okay, just for those who want some sort of correlation, we try that. Attribute is a fundamental unit of each item, and this attribute is the key value pair. So book has an attribute, as I said, about author, about the title of the book, about various other things. All these are attributes. So each of the key you can think of as one attribute. Each key within the item is an attribute of the item. So how many keys you have within an item, that many attributes you have in the item. Following this, as I said, when there are multiple keys, you want at least one key based on which there is certain uniqueness to the item. And this is called as a primary key. So every item must have a primary key. So this primary key is the one based on which you will fetch an object. So if you want an item, I call it as an object, but if you want an item from a table, you will fetch it using the primary key. There are two kinds of primary key. The first is known as a partition key. So you can say all the items in this table will contain a partition key. That is, it will be a single key, only one key. And that key value, the value of that key must be unique. That is, the key has to be present in every item. For example, in the example that I gave about you having a bookshop, you can have a key called product ID. So the product ID must be present in every single item that you have. So the product ID is an important part for those items. In certain cases, you can have what is called as a partition key and a sort key. This is useful in certain cases. For example, let me say that I'm listing out the albums of various musicians, in which case I can have the name of the artist as a partition key and the album name as a sort key. Now, automatically you will realize one thing. If I put in hundreds of musicians, each musician will have multiple albums. So the partition key in this case is not unique. That is, a musician has multiple albums, right? So in the case of a partition and a sort key, what is required is two keys can have the same, two items can have the same partition key, but the sort key must be different. That is, the combination of partition and sort key must be unique for each item. So this is something that you must tell when you create a table. So when you create a table, you must say whether you have a partition key alone, in which case every item will have one key which is unique, or you can have a partition and a sort key, in which case the partition plus sort key must be unique for each item. Now, why is this partition key used? This partition key is used to store your item in a certain place in the disk. So that partition key is taken, they calculate a hash value, and based on that, they put your item on a certain disk, a certain place in a disk, such that when you want to get the item back, you go and query on the partition key, they calculate the hash of that, and immediately they know where your item or in which part of the disk your item resides, and they will go fetch it up. Of course, this whole thing is much more complex there, but I'm just trying to simplify this for you in order for you to understand how the partition key works and why a partition key is needed. So your partition key will dictate where your data is stored, and the fetching happens based on the partition key. Then in case of a partition and a sort key, what happens is the partition key will determine where your data is stored, whereas the sort key, the same place, different items are stored of the same partition. In the same partition, multiple items are stored where the sort key will vary, and the sort key, the items are stored in an ascending order, right? So if you see here, the artist name is called as No One You Know, whereas there are certain song titles which are here, and based on the song title, you will find that it is being stored in an ascending order. So the partition and sort key works this way. So the partition key determines which partition in the disk it is stored, and the sort key, in the same partition, items are stored in the ascending order as per the sort key. This is a technical detail on how partition and sort key work within DynamoDB. Now, you can also create secondary indexes. Now, secondary index is an index which allows you to query the data in a table using an alternate key. For example, if you have an album title and the artist as your partition sort key, you also want to query based on the year of release. So you want to know in the 1998, what albums were released, right? That's not initially there. You cannot query on that. You first have to query on the partition sort key, and then you will filter out this data. Instead of that, you can also define a secondary index, which means that which will allow you to query on that index. So you can query on the year of the release of an album. For that, it forms another table, and for that, you need to specify throughput and all. That's a different thing. I mean, just at a global level, I'm telling you. So there are two kinds of secondary index. One kind is called as a global secondary index. In this index, both the partition key and the sort key for the secondary table, you can call that, will be different from that of the primary one. So you have a different partition key and different sort key, and you can query on that as far as secondary index concerned. There's also another secondary index called as local secondary index. In this index, you have the same partition key as the table. So your partition key is same as that of the table, but the sort key is different. They allow you to go up to 5 global secondary index and 5 local secondary index. Finally, I'll just talk briefly about DynamoDB streams before I go and show you a small demonstration of DynamoDB, and then you will get things much more clear. So DynamoDB is an feature which captures any modification that happens to the DynamoDB table. That is, if you add a new item, you get an event generated. If you delete an item, you will get to know that, and you can also get a message which says, okay, this item has been modified. This was the item before the modification. This is the item after the modification, and so on. So that's what DynamoDB streams does. Okay, so this is an example. So if there is any change, a new item is added, the stream record is sent to DynamoDB streams. From DynamoDB streams, you can link to something like AWS Lambda, and Lambda can in turn, interact with any other service. And an example of this could be, which is given in the Amazon manual also, is that let's say you are using DynamoDB to store the names of people who are subscribing to your site. So somebody subscribes to your product or your site. As soon as somebody newly subscribes, you insert that person's name into the table. The moment you put that item into the table, DynamoDB generates that stream record and invoke this Lambda function. The Lambda function will take that person's email ID and will interact with something like Amazon simple email service and send out a welcome mail automatically. So the person will receive a welcome mail saying, thanks for signing up for us. These are all the features that we have. You can do this with our product, etc., etc. So that's how DynamoDB streams will help us. Okay, so this sort of completes an overview of DynamoDB. So let me show you a simple example on DynamoDB, and after that I will take questions from you. So let me go to my console. Here is my Amazon console. I go to services, and within this services, I will go to the database service under which I have DynamoDB. Now let that load up. I'm just waiting for the DynamoDB to come up. Okay, so I don't have any tables in this particular region. Also remember, DynamoDB is region based. If you want this database to be, it's a very highly available database, so that they do internal replication of your data, so you don't need to worry about losing data. But if you are too worried about a disaster recovery scenario where you think a complete region can go down, then you can replicate this tables as well. So they give you a replication option as well. Again, not going into much of detail on that because we don't have that much time. So let me go ahead and create table. Now, when I am going to create this table, all I require is the table name and the primary key. Now, you are not going to say how much space you want, because like I said earlier, you don't need to specify any space. Whatever you write, the space will automatically be added to it. I mean, more and more space comes up. So let's take a table name. Let me say, what I want to say, bookshop, let me say, as my table name. And let me have a partition key. Again, if I want a sort key, I can put up a sort key here. So the partition and sort key both can be there. But let me say I want only the partition key. Then the partition key would be, let's say, a product ID. And you can say what sort of key it is. It's a binary key, where you put 0 or 1, or is the string, or it's a number. So let me put this as a number. My product ID, I want it to be number. And then you have a table setting. In the table setting, you can see that there is default setting. The default setting is there are no secondary indexes. If you want it, you can define here. There is a provisioned capacity of 5 reads and 5 writes. That, of course, is the number of reads per second, number of writes per second that you want. And there are basic alarms which come. DynamoDB has come up with new features like auto scaling, the caching, etc., etc. Again, they are slightly advanced ones, so I'm not taking it up here. So let's, if I don't use these default settings, then I can go and add my secondary indexes. I can add provision capacity. I can look at auto scaling and do that. And if I want an IAM role and all that, we can do. But I'm going to use the default setting for the time being. And then I'm going to go and create this table. And now this table is getting created. But what I want to also tell you about DynamoDB is mostly used using the programming languages. So you need an SDK, and in the SDK is where you will mostly use this, because DynamoDB is for a huge database. We are talking about scaling a database which scales into thousands and thousands of entries. So for these, you will probably not want to go through this console and do, but this is more for you to understand the basic concept. But most of the time, DynamoDB is for looking at, is for programmers. So you program it by putting items, deleting items, getting items, etc., etc. But here, let's go ahead and see this. So I've created a table called bookshop. As you see, when I created a table, I did not give any schema. If you are familiar with database, if you you generally end up creating tables and things like that in a database. You first create a database, and then when you create a table, you have to say what are the columns, and each column what is the data type and so on. I've done nothing of that sort. I've just said create a table. As I said, this table is nothing but a big bucket which is going to hold all your items. So think of it that way. So let's go to items, and I want to create an item. Okay, so we said there is a partition key. So every item must have the product ID number, right? I have a product ID that must be there for every item. So let me put this as 001, and then I'm going to append author name for this. So I go and say author name. Let's take somebody, say Chetan Bhagat, and let's take another author name, append one more string. Let me see, where's it gone up? Oh, yes, just one minute. Let's append. Oof. Let's. Oh, yeah. I think it's a string here. So let me put the title. Say, let the title be something like 2 states, and then let me append another number. This time I want to have a look at the price of the book. So the price of the book could be 250 rupees, whatever, and I save this. So you can see here, you have a product ID called 001, Chetan Bhagat, the price is so and so on. So let me create another item. Again, you will see that the product ID being required field will appear there. So let me, and it has to be unique. So I put it 002, and then I add append one. Now in this case, I would say I want a model. I'm going to store a pen. So the model could be Parker, and then I want to store a append again a string here. This is and I want to say type of the pen. So let me say it's a fountain pen. Then I can again append one more, and once again go up and say color of the pen. Let's say this is color of the pen, and I would say it's blue, and finally the price of the pen. So I put a number and put a price. So price could be 300 rupees, for example. Now you see we have 2 different items, and each of them has a completely varied properties, right? One has author name, and it has a title. Other has a color, it has a model, right? Price is the only thing which is same about them. So all they must have in common is a product ID, which is the primary key based on which you can search. So you can search based on, give me what is product ID 10, 20, or whatever. Or let's say even if I can create another item like product 003, I can say I append a string, and the string could be an author. So let's say Robert Ludlum, and then I want a title. The title could be Born Identity, right? Now let's say here, if you see, I'm going to add another thing. I'll append a number and call this as ISBN number. Let's say ISBN, right? So ISBN number, so let's say 987654, something like that, and then the price. Now what I want to show you here is how easy it is to expand the attributes of a very similar item. See, so in one case we did not have this ISBN number. In the other case, I can easily add an ISBN number. So I don't need to go ahead and try adding one more column to my table and all that. All I need is, okay, I get another book which has some more attributes, right? I just go ahead and add those attributes in. So this is an idea for you on what it means that you do not have a schema available there. You don't have a schema, and without schema, it gives you a lot of flexibility. And secondly, it also maps to the programmers. So programmers have certain data structures. They can write the data structures directly into the database. Whereas if it's a RDBMS type of a thing, they have to write different values of the data structure to different tables and so on. They generally call this as an impedance mismatch when it comes to programmers versus RDBMS. Whereas in the cases like DynamoDB, you can have a data structure which can be directly written as a complete item into the database. Okay, this is a sort of an overview. Of course, there's a lot more to be told about DynamoDB, and so if you at a later point in time want to check that up in our CloudSiksha course, you will find a lot more other things like what is a consistency model, how do you provision read-write capacity, and so on, right? And of course, for generally webinar people who have registered for the webinar, you will get a coupon and we'll mail it to you, and you will get 10% off on all the courses. So let me stop sharing for time being, and then let me go ahead and start answering your questions. So kindly go ahead and put your questions in the comment section, and I will answer the questions. Okay, as you are typing into the comment section, let me go ahead and answer a question which I got earlier on mail as to why do people want to use NoSQL and not RDBMS? The answer is that no, not that people don't want to use RDBMS. RDBMS is still very much used and is very important in more than one case. The reason, as I told you right in the beginning, the reason why people go for NoSQL type of databases, say in case like DynamoDB, is the extreme scalability that it allows. The partitioning of data, the repartitioning of the data, and the way in which things are fetched, the way in which your data is retrieved, everything ensures that you get a excellent speed of that. So scalability and performance when you're dealing with large amount of data, where you need the data to be distributed across various disks. In that case, this is a very good solution. And as you saw, there could be some places where the requirement for scalability, the requirement for performance may be more than the requirement for consistency. Databases do offer you great consistency. They have the asset requirement that they have. Those will all be there, but the distributed nature of NoSQLs and the scalability of NoSQLs give them an edge over RDBMS in certain cases. So there's another the question is about again which sort of situations you use. Again, I have already explained to you where you would get more need for NoSQL, the scalability that and all that. Shanmugam asks if we can do all these things using CLI. Yes, you can do all these things using CLI. The CLI does provide you to create a table, add an item, and so on. That is available. But mostly the DynamoDB is mostly used with programming. In programming is what helps you ensure that you can query the table, you can scan the table and so on, and get the data that you want. You can filter it out and all that stuff. There was also a question about how the integrated DynamoDBs with other services in AWS. DynamoDB integrates especially with especially with Lambda, as I said, through DynamoDB streams. Through streams, you can pass it to Lambda, and Lambda can take the streams and then do an action on that. Prashant asks, what are the implications of not having ACID? Yes, this does have a bearing on the consistency of the data. So the data in certain times you can be inconsistent. So if you can afford that inconsistency, or you believe that inconsistency is not going to be a big problem for you, or you have coded to take this inconsistency into account, then you may want to sacrifice the lack of consistency for getting the sort of scalability and performance that these NoSQL databases give, especially DynamoDB gives. Shanmugam has asked us, what is the preferred programming language? Well, there is no preferred language as such. The SDKs are available in multiple languages. You have SDKs for Java. A lot of people code in Java. You have SDK for JavaScript, which is Node.js. You have SDKs for Python and Ruby and PHP. So all of them, and of course you have for .NET, C#. You can use any of them in which you are comfortable with. There's no preferred language as such on this. Yeah, another question which I had got earlier is, what type of NoSQL databases does Amazon as such support? DynamoDB, we said, is sort of a document database. Amazon also supports Redis. Redis is a key value database. Amazon's Redshift is a columnar database. So you have key value, you have a document, you have a columnar database, all of them being supported in AWS. So another question someone had asked is, in the exam, would you have things like when to use DynamoDB and all? Would they give you? Yes. There are DynamoDB questions do appear, and one of the things about DynamoDB is whenever a question comes which says, I want to store huge amount of items of data where they don't specify, it should have infinite capacity type thing, and then they talk about indexing data and so on. In those cases, you are looking at DynamoDB as this. So partitioning, keywords like partitioning, indexing, storing data without limit, all these are important keywords where the answer is mostly going to be DynamoDB. Shanmugam has asked us, so we can use shell scripts to run commands in Linux? Yes, perfectly. Yes, you can use your shell script, and you just need to download the CLI for Amazon AWS. Use the CLI for AWS and then run all the commands in a shell script that you are familiar with. It could either be whether it's whatever shell script that you want to use. Okay, I think that's most of the questions that I got there, and which I've seen here. If that's all, so let me thank all of you for watching this. I hope you got some idea of it. As I said, if you have any other queries, you can always mail me, and we will be having these seminars regularly on different subjects. And please do join in next time when you're there. And you may want to subscribe to this channel. You can always hit the subscribe button. And our website is academy.cloudsiksha.com. If you've not been there, please go ahead and have a look. We have a lot of AWS courses now, and more will be coming in the coming months. So once again, thanks to all of you. You will have this recorded video available to you soon, and we'll send you the link for this soon. Thanks once again for joining me. Bye.